Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 22 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 868, binary gap. So in this problem, you are given a positive integer n. We have to find and return the longest distance between any two adjacent ones in the binary representation of n. If there are no two adjacent ones, then in that case we have to return 0. So here two ones are adjacent if there are only zeros separating them, possibly no zeros. The distance between two ones is the absolute difference between their bit positions. For example, the two ones in this have a distance of 3. So here see 1 0 0 1. So let's say this is at 0 index, this is at 1 index, this is at 2 index, this is 3 index. So what we are doing, we are just doing here we have 1 and here we have 1. So here 1 is at 3 index, 1 is at 0 index, so 3 minus 0 is 3. That's it. Clear? Now here if you see the constant, so constant is n is from 1 to 10 power 9. All right. So here now if you see this example number 1, so n is equal to 22. So how we write this 22 in a binary form? So this bit value is, well, let's say 1, this bit value is 2, this bit value is 4, this bit value is 8, and this bit value is 16. So we write 22 like this: 1 0 1 1 0 in binary form. Clear this part? 16 plus 4 20, 20 plus 2 22. All right. Now here the distance between these two, here if I just give the indexing, let's say this is at 0 index, this is at 1 index, this is at 2 index, this is at 3 index, this is at 4 index. So distance between them is nothing but 2 minus 1 is 1. And what is the distance between them? 4 minus 2 is 2. So this and this, they are adjacent. This and this, they are adjacent. But this and this are not adjacent because there is 1 in between. So here the first adjacent pair is this, you can say 1 0 1 with the distance of 2. All right. The second adjacent pair, let's say these two with the distance of 1. The answer is the largest of these two distances, which is 2. All right. Note that this and this is not a valid pair since there is a 1 separating the two ones underlined. So I hope that this part is clear. Now how we are going to solve it then? So that is very easy now. So let's see how we are going to solve it. So what I will do, I will create few variables. So I will create one variable, let's say last seen. So initially last seen value is equal to -1. So this last seen index is going to store the last seen value of 1 in the binary form. And I will create one variable max gap. It is going to store the maximum gap. So initially it is 0. And I will create one variable index and I am going to set it to 0. So initially my index is equal to 0. Done. Now after that what I will do, so here I am going to run one while loop. So I will say while my n value is greater than 0. This is what I'm going to do. And inside this while loop, what I will do, I will just do the AND of this n value, right? I will do the AND of this value with 1. So I will say if n and AND with 1, and if this value comes out to be equal to 1. So here what I'm checking in this case. In this case, I am checking that if my last bit here is 1 or not. So this is what I have initially. Now if I do the AND of any number with 1, so basically I am checking about this last bit only, right? So if this bit is 1, then in the output I will always get 1. But here if this bit is 0, then in the output I will always get 0, because rest all are 0. So here I always will get 0. But here in this position I will get 1 if this is 1, and here in this position I will get 0 if this is 0. So right now it is 0, last is 0. So it is not 1. So there's nothing I need to do right here. Then what I will do, I will simply right shift this. I will simply right shift this number by 1. So n, and here right shift by 1. So if I'm doing the right shift by 1, So new number I will get something like this, 0 1 0 1 1. This is what I will get. I just did the right shift by 1. Clear? And this number I did the right shift, and now this index is done. So I will increment the index. So index value I will say index plus plus. So I have already checked this, na? So index plus plus. Done. This is done. Now this is what I have, and still if you see n value is still greater than 0. Now again I'm going to do the AND operation of this new n value with 1, and I see that last bit is 1, 0 1 0 1 1. And if I do the AND with 1, I am going to see these all four are zeros, and here it is 1, so here I will get 1. So yeah, it is 1. But here I will see that if I am seeing the 1 for very first time, so here in the inside this I am going to write one more if condition. If last seen is not equal to -1, so right now it is equal to -1. So I am seeing it for very first time. So what I will do here, I will say that I will not update anything whatever inside this if condition. Out of this if condition I come here, and what I did, I just update my last scene equal to this current index. So index I have already incremented from last time, so now last scene is going to become 1, right? This is what I did here. Last scene done. Okay, now again right shift this n by 1, so I'm going to get 0 0 1 0 1. This is what I'm going to get, and index is going to increment it to 2. Index is going to increment to 2 now. Done. Now again this number is greater than 0. Now again I do this n and 1, and now again it comes out equal to 1, but this time last scene is not equal to -1. That simply means in the past I have seen my last scene at some index value. So in general if I say, I will just simply write this as nothing but index value. So I have seen this, right? Now inside this what I will do, I will update the max gap. That is your code, that's it. So max gap is nothing but the math dot max of the max gap, and here the current index minus last scene. That's what you are going to do. So here uh, max gap as of now is 0, but here in this time index is 2, and last scene was 1, so 2 minus 1 is 1. So I am going to get the distance of these two, that is nothing but 1. So now after that again I will just right shift it with 1, I will get something like this, 1 0. Again this value is greater than this, so now this time it is 0, so I don't have to do anything. And here uh, I am again going to right shift, and here index is always incremented, right? So previously also it is incremented to 3, now it's going to increment to 0 1 2 3. Right now after that I'm going to here, right? So again now I'm going to get something like this, 0 0 0 1. So now it is 1. So now, and last scene also I have updated from last time. So last time I've seen this at 0 1 2, so this was the last time, last scene index of this two. And now again here I will update. So previous max is 1, and now 4 minus 2, so I will get what, 2 1 comma 2. So max is 2, so I will take 2 into consideration, and this time I have seen this at 4 index, so I will update 4. Then again it will go right shift, so I will get around 0 0 0, and this number becomes 0, so that's it. So max is 2. So this is actually what you need to write, that's it. Okay, this is what you need to write in the code. Okay, and here if you see example number 2, n is equal to 8, so only one occurrence is there, so definitely you have to return 0. And here 5, you write it like this, the distance between them is 0 1 2, so 2 minus 0 is 2, that's it. So now let's write the code. So I'm going to write the same thing whatever I have written here now. So very easy code actually, nothing complex here. Int last, let me just maximize a little bit, last scene value is equal to -1, and here int max gap value, so it is also going to be 0 initially, right? And then after that just take one value of index and set that value of index to 0 also. And then after that you have to simply run one while loop, and inside this while loop you are going to check if n is greater than 0. And here I told you you have to check the last bit now. So if and here in between n, and you are doing with 1, so if the last bit, if it comes out to be 1, right? So in that case only we have to do few things. So here what I'm checking, if current bit is 1, this is what I'm checking here. And here what I will do, I will say if the last seen value is not equal to -1. So if I am seeing this, not the very first occurrence of this, right? And here I have to update always my last seen value to the current index, so where I am seeing this one for the last time, right? So this I only need to do here if I'm not seeing it for very first time. So in that case, my max gap will be updated. So max gap is going to be math dot max of max gap, and here you have to write index minus last seen. That's it. This is what you have to write here, and this is done here. And here always, once this is done, always you have to right shift your ny1. So here you are doing right shift, and indefinitely index will be incremented. So one index is checked, now we are moving to next index. That's it. That's it. And here you have to simply return max gap. This is your code. Very easy. Very easy, right? Now let's run it. So see, all the test cases has been passed. Now let's submit it. So see, our solution is accepted, right? And what is going to be the time complexity for this one? So you can say the time complexity is going to be of log n, or you can say of 32 as well, right? So why of 32? Because at max we can have 32 bits only in the integer. So you can say of 32. And why I'm saying of log n? So log n I'm saying because here let's say your n value is 8. So 8, so log 2 of n. Why I'm saying this as time complexity? Because if you write it 8 here, so you are going to write it like this: log 2 of 2 power 3, and this is nothing but 3 into log 2 base 2, and this is nothing but 1, right? So you are going to get 3. So what is 3 plus 1? You have to just do plus 1, so that is nothing but 4. So in 8 you see that you have total 4 bits. That's the reason, right? So log 2 1 value is 0, and if you do 0 plus 1, so that is nothing but 1 bit for 0. If you do log 2 of 2, so that you are going to get 1. But if you do 1 plus 1, so always I have to add 1, so you are going to get 2, because you have 2 bits here in 2 in binary form. If you do log 2 4, so you are going to get 2 here. 2 plus 1, if you do 3, so you are going to get 1 0 0 1 2 4, right? So log 2, it's nothing but log 2, then 2 power 2, so this is nothing but 2 into log 2 2, that is nothing but 1. So 2 is the value you are going to get. But if you do plus 1, so you are going to get the number of bits that you will see here. That's it. So that's why I'm saying in general you can take the time complexity as log n, or you can say of 32. So anything is fine, right? So I hope that you guys are clear with this problem, and if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in next video. Thank you. Bye bye.